Welcome to the Deep Dive, the place where we take a monumental stack of sources, distill the essential wisdom, and deliver it straight to you, the learner. Today, we are cracking open the digital blueprints of the modern world. We're focusing on the human architect behind one of the most transformative technologies of the last 30 years, Python. And this isn't just about a language, it's really the operating system of the entire data science boom, and we are going deep into the mind of its creator.
We really are. Today is a comprehensive biographical deep dive into Guido van Rossum. He's the Dutch programmer who held the fascinating and frankly hilarious title of the benevolent dictator for life, the BDFL of Python for decades. His story is just the perfect example of how a single person's aesthetic and, philosophical commitments can end up shaping global technology and collaboration.
That BDFL title, Benevolent Dictator for Life, it's so loaded with meaning in the open source community, isn't it?
Oh, absolutely.
It signifies authority, vision, but also a degree of humor that I think really reflects the language itself. Our mission today is to go way beyond the Wikipedia entry. We're tracing his life, his very specific design philosophy, and his career pivots to truly understand why. Why did Python succeed where so many other scripting languages failed?
And we're going from his rigorous academic roots in the Netherlands through the turbulence of the early dot-com bubble and straight through to his current and I think very unexpected gig at Microsoft.
Exactly. The sources we've gathered give us this meticulous timeline of his origins, the precise moment of Python's conception, which, believe it or not, happened during a Christmas holiday.
Which is just the best story.
It really is. And we'll look at its underlying intellectual pedigree and, of course, the explosive global dominance it now commands. We're really looking for those foundational design decisions.
Right. But why the obsession with readability? Why did he prioritize the beginner while still maintaining enough power for the expert? Those are the questions we need to answer.
So if you want a shortcut to understanding the foundational choices behind the code that powers everything from, data science infrastructure to the back-end systems of giants like Google and GitHub, you've come to the right place. We are looking for those aha moments that define this man's legacy.
Okay, let's unpack this and start right at the beginning. So Guido van Rossum's story, it begins so far from the typical narrative of, the Silicon Valley dropout success.
Completely.
He was born in The Hague, Netherlands, January 31st, 1956. So he's currently 69 years old. And what immediately stands out is the intellectual rigor that just defined his early years. He didn't just drift into coding.
No, not at all. He had this deep academic base in mathematics and computer science. And that combination is just so crucial. He received a master's degree in mathematics and computer science from the University of Amsterdam, graduating in 1982. This academic grounding, it gave him the discipline to think about programming, not just as a series of instructions, but as a system of, proofs, structures, and logical consistency. And the sources highlight a genuinely surprising non-coding achievement that, once you realize the connection, it just makes total sense as a precursor to designing Python. You have to tell us about the International Mathematical Olympiad.
It's a spectacular detail. It really is.
Yeah.
In 1974, so this is before he even finishes higher education, van Rossum earned a bronze medal in the International Mathematical Olympiad, the IMO. And this competition is renowned globally for its difficulty. I mean, it requires tackling highly abstract, non-standard, and just completely non-routine problem solving.
So, okay, why does an IMO medal matter when we're talking about Python? I mean, on the surface, it seems like ancient history.
It matters immensely because designing a robust, elegant programming language is, at its core, an exercise in applied abstract mathematics. It just is. The IMO tests your ability to create elegant, minimal solutions for incredibly complex logical problems.
Okay, I see where you're going with this.
Right. Python's design philosophy, there should be one, and preferably only one, obvious way to do it. That is a direct reflection of that mathematical rigor. It's the search for the most efficient, the most beautiful proof. That early affinity for abstract systems is the absolute bedrock of Python's consistent, clean syntax.
That connects the rigor of his youth directly to the consistency of the language we all use today. It sets the stage so beautifully. But the connections to design and systems, they run even deeper, right into his own family, which links directly to this concept of readability.
Absolutely. We have to talk about his brother, Just van Rossum.
Just J-U-S-T.
Exactly. He's an accomplished programmer himself, but also, crucially, a type designer. And in an era where, a lot of open source projects were purely functional and, let's be honest, aesthetically pretty rough, The Van Rossum family brought a different focus.
And here's a fascinating nugget from the sources. Just Van Rossum actually designed the distinctive modern typeface used in the iconic Python-powered logo. So why is that important beyond just, looking good?
It's highly significant because it reinforces that core philosophical commitment to clarity. If readability is Python's greatest feature, the ability for engineers to quickly parse each other's code, then that aesthetic commitment starts at the very presentation level.
Yeah, it's a signal.
It's a huge signal that design is not secondary to function, it's integrated. The choice of a clean, distinctive font for the logo, it underscores that the quality of the visual presentation of the code itself, that's part of the user experience.
Okay, so the foundation is set. We have rigorous mathematical thinking combined with an appreciation for aesthetics and clear design. Now let's transition into his professional starting point, the world of Dutch research, which served as Python's literal incubator. Tell us about the Centrum Wiskunde Informatica, or CWI.
CWI in the Netherlands was Van Rossum's first major workplace, and it was a powerhouse of computing contributions, a really important institution. It was there in 1986 that he wrote and contributed a small but incredibly useful piece of functionality.
Oh, yeah.
The glob routine to BSD Unix.
Okay, so for those of us who aren't low-level systems engineers, what exactly is glob? And why is that seemingly minor contribution such a crucial indicator of his early approach?
Well, glob is essentially a utility for file pattern matching. It lets you search for files using wildcards.
Like when you type .py in the terminal to list all your Python files.
Exactly that functionality. And the point is, Van Rossum didn't just write research papers. He wrote crucial, low-level utilities that became institutional parts of the computing infrastructure. It demonstrates his early focus on creating practical tools that solved everyday pain points for Unix developers, a focus that would, come to define Python itself.
And while he was writing these utilities, he was also heavily involved in developing a language that would serve as Python's immediate technical parent, ABC.
Yes, ABC was the laboratory. And Python was the successful, refined product that learned directly from ABC's successes, but also its limitations. Van Rossum explicitly stated his indebtedness to ABC, citing its direct influence on Python, particularly its high-level data types and its focus on clean, mandatory structure.
So what were the key innovations that ABC introduced that Python inherited? And maybe more importantly, what were its constraints that Van Rossum was so determined to overcome?
The big inheritance was the idea of high-level structure and expressive syntax, just minimizing all the boilerplate code that C and other languages demanded at the time. ABC pioneered ideas like simplified data handling and built-in complex types.
But it had a fatal flaw, right?
It did. Its constraint was its all-or-nothing approach. ABC was designed as a teaching language and a system replacement. It was meant to be used in isolation. This made it incredibly difficult to interface with the existing Unix infrastructure, with C libraries and system calls.
So it couldn't play well with others.
Exactly. Van Rossum saw the genius of ABC's clarity, but realized that if a language couldn't easily talk to the existing world of C and Unix, it would just remain a curiosity. It would never become a global tool.
That provides fantastic context for the eventual design of Python, keeping the beauty of ABC, but making it practical enough for Unix C hackers. But before Python fully took form, he was also engaged in the very earliest days of the World Wide Web, which feels like a surprising historical detour.
It's a remarkable parallel career thread. Van Rossum created Grail, which was one of the very first web browsers. But the key point is that Grail was notably written in Python.
Wait, so Python was creating its own early, complex, real-world application? That's kind of the ultimate stress test for a new language.
It is. This wasn't just some theoretical language development. It was immediate, real-world application building. Grail showed that Python could handle complex tasks, graphical interfaces, network protocols, and on top of that, he was actively engaging in early discussions about the HTML standard.
The fundamental markup language of the web.
The very same. This placed him right at the birth of the internet infrastructure, not just as a developer, but as a thought leader on how to structure information and interaction. It proves that by the early 90s, Python was already seen as a viable, productive tool for building the future.
Okay, let's move to the actual birth of Python. This is where the historical rigor meets that kind of delightful, casual anecdote that we just love to share. The origin story is famously tied to a holiday break.
It is the most charming origin story in computer science, hands down.
Yeah.
Python was conceived in December 1989. Van Rossum was facing an empty office. CWI was closed for the holidays, and he was specifically looking for a coup, and this is a quote, a hobby programming project that would keep him occupied during the week around Christmas. He decided the project would be writing an interpreter for a new scripting language.
It's almost impossible to reconcile that low-key, bored over Christmas motivation with the global impact of what he created. But this wasn't an entirely unplanned endeavor, was it? He knew exactly what problem he wanted to solve.
Oh, he had highly specific design goals. He wanted this new language to be a descendant of ABC, retaining its clarity, but he wanted it specifically designed to appeal to Unix hackers.
The pivot point we just discussed.
Exactly. Python had to be simple enough for a beginner, but powerful enough for a professional C programmer to use for glue code, for system scripting, for automation.
So it was targeted evolution. He was trying to bridge that gap between academic elegance and real-world C-level performance demands, all over a quiet Christmas break.
Precisely. And if we look at that technical lineage, we can actually trace Python's intellectual history back even further than ABC, which gives us the deeper why behind its intuitive syntax today.
Let's connect those dots. Python is the descendant of ABC. Where does ABC come from?
ABC itself was inspired by Setlal, the set language. This is a critical point that often gets overlooked. Van Rossum noted that an ABC code developer, Lambert Meertens, spent a year specifically with the Settle group at NYU before they finalized the ABC design. And Setlal, developed at NYU way back in the 1960s, was based explicitly on the mathematical theory of sets.
That's a huge academic connection. The theory of sets is fundamental to all modern data structures. So how does that mathematical origin manifest in the Python we use today?
It manifests in Python's incredibly natural handling of high-level data types, like dictionaries, lists, and sets. Unlike languages that force you to constantly manage memory and pointers, Python allows you to interact with data structures using operations that feel mathematically natural, like union, intersection, and difference for sets, or key-value lookups for dictionaries.
It's a higher level of abstraction.
Much higher level. This expressiveness, rooted in set theory, is why Python feels so intuitive when you're dealing with data science and complex structures today. It was built from a sophisticated academic foundation designed to think clearly about relationships and groups of data.
That explains why the code feels less like instructing a machine and more like, I don't know, writing out a clear concept. Now let's move to the most famous and most crucial anecdote that captures Guido van Rossum's personality: the naming of the language.
This is the detail everyone remembers. And the common misconception is that Python was named after the dangerous snake. But that's completely incorrect. The actual inspiration, which truly encapsulates the culture he was building, came from the beloved, eccentric British comedy series Monty Python's Flying Circus.
Why is this detail so important? I mean, it's funny, sure, but how does that influence the global success of a programming language?
It sets the entire tone for the community. Choosing a name rooted in irreverent, witty, and slightly absurd comedy immediately signals that the project is not taking itself too seriously, even if the technology is very serious.
It gives it a personality.
It injects personality and levity into a field that was often characterized by dry academic seriousness. It made the community inviting. The culture of early Python was one that valued creativity, fun, and breaking conventions, a spirit that Python embodied by, for instance, enforcing readability via mandatory indentation. That was a revolutionary and, frankly, controversial concept at the time.
And speaking of that design philosophy, that focus on what the language should be was formally laid out in 1999. This leads us to the heart of Python's enduring success: the Computer Programming for Everybody proposal, or CP4E.
This was a pivotal moment. The funding proposal to DARPA, submitted in 1999, it wasn't just a request for cash. It was a formal articulation of Python's ultimate vision. This was before it achieved its current level of, ubiquity. It established that the goal was not just to make a better scripting language, but to democratize programming itself.
So let's break down the 4 core goals defined in that proposal, because they are the intellectual blueprint for its global dominance today. Goal 1 was all about achieving power without sacrificing simplicity.
Yes, Goal 1 stipulated that Python needed to be an easy and intuitive language just as powerful as major competitors. This was a really bold stance at the time.
Why was it so bold?
Well, back then, if a language was easy to learn, it was often dismissed as a toy language. It was seen as lacking the performance or capabilities of, say, C++ or Java. Van Rossum just completely rejected that trade-off. He committed Python to handling complex tasks, system interaction, and eventually the massive data operations we see today, while demanding that the syntax remain accessible and intuitive.
That balancing act, that's what must have first attracted scientists and other non-traditional developers.
I think so. The second goal then addresses the structure of the entire project, defining its collaborative future.
Which was foundational.
It was. Goal 2 was, Python must be open source, allowing anyone to contribute to its development. By committing to open source from the very start, Van Rossum ensured that Python would benefit from global, distributed collaboration, rapid iteration, and crucially, community ownership.
But wait, in the late 90s, wouldn't committing to open source and inviting anyone to contribute have posed a huge risk? There is fragmentation or dilution of quality. How did he manage that growth without losing focus on the mission?
That's where the BDFL structure comes in, which we'll get to later. But it's also about the clarity of the design philosophy. The open source commitment was essential for growth, for sure. But Van Rossum's single authoritative vision acted as a constant filter. It ensured that contributions adhered to that core principle of readability. The community could submit and iterate, but the central aesthetic and technical decisions were guided by the BDFL, which prevented the project from fracturing under competing ideas.
That makes perfect sense. The third goal, though, is maybe Python's defining feature in the mind of the general user: readability.
Absolutely. Goal 3 mandated code that is as understandable as plain English. This is where the architectural brilliance really lies. And Van Rossum enforced this readability primarily through one key mechanism: mandatory significant whitespace. Indentation is not optional. It defines code blocks.
Let's just pause on that technical choice for a second. Mandatory indentation was highly controversial at the time. Why was it so revolutionary, and what impact did it have on collaborative projects?
It was revolutionary because it forced a coding style. In most languages, you use curly braces or keywords to define structure, and indentation is just for human convenience. It's suggestion.
But not in Python.
Not in Python. In Python, indentation is the structure, and the consequence is immediate. Every single piece of Python code, no matter who writes it, looks basically the same. This drastically minimizes cognitive load. When you open a new repository or look at a colleague's code, you don't waste time deciphering their personal formatting style.
It just works.
It just works. It ensures ease of maintenance, it accelerates code reviews, and it makes massive open source collaboration dramatically simpler because the computer is enforcing the human readability standard. It truly makes the code as understandable as plain English.
He essentially turned an aesthetic preference into a technical requirement, and it simplified life for everyone. Okay, finally, the fourth goal focused squarely on practical application and speed of deployment.
Right. Goal 4 addressed suitability for everyday tasks, allowing for short development times. This established Python as the ultimate scripting or glue language. He ensured it had vast libraries and could integrate quickly with other systems. This focus on rapid prototyping and short development cycles is why major tech companies, especially those focused on agile development and continuous deployment, adopted it so quickly.
They could build and test functionality in a fraction of the time.
A tenth of the time required by more verbose compiled languages.
Exactly.
It's clear this 1999 proposal wasn't just, aspirational. It was a foundational commitment that really defined the next 2 decades of the language. It secured Python's destiny not just as a better tool, but as a tool designed for the widest possible audience. So, having established that philosophical foundation, let's trace Guido van Rossum's career path through the subsequent tech boom and bust. Because it was far from a straight, easy ascent. His transition from research institutes like CWI and NIST to the commercial world in the early 2000s was a true roller coaster. The early 2000s were highly transitional. They were fueled by the excitement and then the subsequent chaos of the dot-com boom. Van Rossum and 3 other core Python developers, they made the leap into the startup world in May of 2000, joining a company called beopen.com. This was a move to try and secure consistent funding and a commercial home for the Python Software Foundation.
That timing was less than ideal, to put it mildly, given the economic realities of 2000.
Incredibly poor timing. The dot-com bust was in full swing, and beopen.com subsequently collapsed by October of that same year.
May to October, wow.
It's a remarkably fast turnaround. And this wasn't just a corporate failure. It was a moment of genuine uncertainty for the core development team and the future of the language itself.
So after that rapid collapse, where did he find the stability he needed to keep fostering Python?
He pivoted immediately. From late 2000 until 2003, he worked for Zope Corporation.
Zope was a big deal at the time.
A very big deal. Zope was a significant open-source web application server platform and is a huge validation for Python's viability in large-scale web development. Following that, in 2003, he transitioned to a company called Elemental Security.
And while he was at Elemental Security, the sources say he took a brief detour from core Python development, right?
Yes, and this is a great illustration of his foundational expertise. While he was there, he worked on a custom programming language specifically tailored for that organization's internal needs. He wasn't just a maintainer of Python, he was a language architect for hire. It shows his ongoing interest in the design of systems and syntax, proving his skills were transferable to highly specialized needs.
His career really stabilized and gained global visibility when he landed at one of the giants of the era, Google. This move in 2005, lasting until 2012, was a critical turning point for Python's corporate acceptance.
The Google era was absolutely crucial. It provided Python with stability, immense scaling challenges, and, most importantly, financial backing. Google, as an organization built so heavily on Linux and open source, was already a massive Python user, and the company made a huge, groundbreaking commitment.
Which was?
Van Rossum spent fully half of his time actively developing and improving the core Python language while on Google's payroll. This kind of corporate sponsorship of open source creation was revolutionary.
So that commitment means that the quality and features of Python for every single user benefited directly from the resources of one of the world's most powerful tech companies. And while he was at Google, he developed some fascinating internal tools that beautifully connect back to his Dutch cultural roots and his appreciation for art and design.
It's a wonderful recurring motif in his career. He developed Mondrian, which was a web-based code review system written entirely in Python and used internally at Google. And the name, Mondrian, comes from the iconic Dutch painter Piet Mondrian, who's famous for his geometric abstract canvases. All sharp lines, clean organization, minimal elements.
That is a perfect name for a tool dedicated to clean, organized, structural code review.
It's perfect. And he didn't stop there. He also developed Rietveld, a related software project. This one was named after the Dutch designer Gerrit Rietveld, known for his strikingly simple, geometrical, and functional furniture, like the famous red and blue chair.
These naming choices are more than just trivia, aren't they?
Oh, much more. They showcase Van Rossum's consistent belief that software development should aim for functional elegance and visual clarity, just like the best Dutch design.
It really reinforces that Zen of Python idea, that complexity should be hidden behind simplicity. So he left Google in late 2012 and moved to the cloud file storage company Dropbox, starting in January 2013. What was the focus during the Dropbox years?
The Dropbox years, which ran until 2019, shifted the focus from pure language creation to applying Python at a massive corporate scale. Dropbox's backend was heavily reliant on Python, and its incredible growth exposed certain limitations of a dynamically typed language when codebases become just sprawling and are maintained by hundreds of engineers.
So the pressure of a hyper-growth tech company ended up feeding features back into the language itself.
Exactly. This is where the cycle of creation, application, and refinement truly completed. One key internal contribution, which he mentioned directly in his retirement announcement, was the influence this environment had on type annotations.
Tell us more about that. For our learner, what are type annotations, and why would a company like Dropbox need them so badly that it influenced core language design?
Right. So Python is traditionally a dynamically typed language. That means you don't have to explicitly declare whether a variable is a number, a string, or a list. The interpreter figures it out at runtime.
Which is great for speed of development.
Great for rapid development. However, at Dropbox's scale, with millions of lines of code, this dynamic typing means errors like trying to perform arithmetic on a string aren't caught until the program is already running, potentially in production.
Which is not good.
Which is very not good. Type annotations are optional hints you can add to the code, and they allow static analysis tools to check the code's consistency before it ever runs.
So this feature was essentially a corporate necessity born from scale, which then improved the language's robustness for everyone else.
Precisely. Van Rossum noted that the need for stronger tools to manage code consistency at Dropbox directly influenced the push for, and the eventual acceptance of, official type hints in Python. It's a perfect illustration of open source development being refined by massive, real-world commercial pressure.
And the Dropbox period culminated in his first major career milestone, retirement.
Yes.
Yes.
In October 2019, he announced his departure from Dropbox and his official retirement, stating that it's been an amazing ride. And it really seemed like a fitting, well-deserved conclusion to a legacy that had already secured Python's place in history.
Except the retirement didn't stick. This brings us to the very unexpected pivot that happened in 2020, a year that provided enough turbulence that maybe retirement seemed a little quiet by comparison.
That unexpected pivot was a major news story in the tech world. On November 12, 2020, Van Rossum announced that retirement was simply boring, and he was joining the developer division at Microsoft.
Microsoft, the company that, for decades, really represented the antithesis of open source and community-driven development. Bringing in the founder of one of the world's most successful open source languages, that speaks volumes about the sea change in the tech world.
It's an incredible historical irony, isn't it? And it symbolizes Microsoft's profound shift toward embracing open source under its modern leadership. His current role at Microsoft is Distinguished Engineer, which is a high honor reserved for the top technical contributors. And crucially, his stated mission was explicit and continued his open source commitment.
What was that mission?
He aimed to, and this is a quote, make using Python better for sure, and not just on Windows.
He specifically called out making Python better for the entire ecosystem, regardless of the operating system. What projects has he been focusing on there that demonstrate this commitment?
Well, his work at Microsoft centers on enhancing the performance and tooling of CPython, which is the core implementation of Python. For example, he has been deeply involved in ongoing efforts to significantly increase the execution speed of Python, which has been a long-standing challenge for the language.
So he's using corporate resources to tackle Python's biggest technical hurdles.
Exactly. Things like the global interpreter lock, the GIL, and overall performance. By dedicating Microsoft's resources to solve Python's fundamental technical limitations, he is once again acting as a powerful steward for the entire community. It proves that even in retirement, his dedication to Python remains his primary driver.
It's the ultimate lesson in project stewardship. For some creators, the work is never truly done. We've used the term BDFL several times, and it is the institutional centerpiece of Guido van Rossum's leadership legacy. Let's define it clearly and discuss why that unique governance structure was so necessary for Python's survival and growth.
The benevolent dictator for life title was the unofficial but critically important ultimate authority over the Python development process. It's not a formal legal position, but a recognition that the final word, the vision, and the most critical decisions rested with Van Rossum himself.
So, dictator, but a benevolent one.
Exactly. The dictator part acknowledged his final veto power on any change, but the benevolent part emphasized that these decisions were always made in the best interest of the language's core philosophical goals, primarily clarity and accessibility.
So why did an open source project, which is theoretically rooted in decentralization, choose this centralized, almost monarchical leadership structure?
The BDFL model was highly effective, particularly in the early stages of a project's life, for one paramount reason: cohesion. Open source projects, when they democratize too quickly, often suffer from fragmentation. That can kill a language before it even gains momentum.
You see that happen all the time.
All the time. Languages fragment into competing, incompatible dialects. Van Rossum's singular, highly consistent vision ensured that every major feature, every syntax change, every community disagreement was resolved by appealing to that core philosophy from the CP4E proposal. This consistency was absolutely key to Python's stability for decades.
But, as all benevolent dictatorships eventually must, that era came to an end. The language just grew too large for one person to manage.
Exactly. And the transfer of power was a landmark event in open source governance. Van Rossum formally stepped down from the BDFL position on July 12, 2018. The decision was prompted by the sheer volume and complexity of maintaining the language, and specifically, the intense community debate surrounding a controversial language feature proposal, PEP 572.
The walrus operator.
The infamous walrus operator. He realized the project had grown beyond the capacity of one individual to shepherd effectively, and that it needed a more democratic, resilient governance model.
So what replaced the BDFL, and how is that transition managed?
The community established the Python Steering Council, which is an elected body of core developers. This marked a definitive shift toward a decentralized, democratic model. And Van Rossum remained a member of that steering council through 2019, which helped ensure continuity and guide the new structure.
And he then made his final step back from governance.
Yes, he withdrew from nominations for the 2020 election for the steering council. This signaled a definitive and final step back from the day-to-day governance and the decision-making process. The benevolent dictator officially handed power to the people, demonstrating his commitment not just to the language, but to the health and longevity of the community itself.
The ultimate success of the BDFL's stewardship is maybe best measured by what happened next. The sheer explosive popularity of Python globally, which has only accelerated since he stepped down. Let's look at the metrics, starting with the biggest barometer of developer activity, GitHub.
The GitHub dominance provides a clear timeline of modern relevance. Back in 2019, Python was already incredibly strong. It was established as the second most popular language on GitHub, trailing only JavaScript.
And that was significant because JavaScript is basically required for the front end of the web.
It's a requirement. But the shift in its ranking, fueled by the data science and AI boom, is just astonishing. According to our sources, the major milestone occurred very recently in 2024. Python became the most used language on GitHub, overtaking JavaScript after JavaScript had held that top spot for a remarkable 10-year run.
That is not just a statistical anomaly. That is a fundamental shift in where developers are spending their time and what they're building. What does that 2024 milestone tell us about the current state of technology?
It tells us two key things. First, the open source community is thriving under the new governance model, proving the transition was successful. And second, it highlights the explosion of fields that rely on Python's simplicity and its massive library ecosystem: machine learning, artificial intelligence, automated infrastructure management, data analysis.
So it's a language of the future, basically.
It's no longer just a great scripting language. It is the default, essential tool for the fastest growing sectors of technology.
And it's not just in the open source community. Its commercial value is undeniable in the job market.
Oh, absolutely. When you look at market relevance, Python is consistently among the top 10, often the top 5, most mentioned languages in job postings globally. Companies need Python developers across every single industry: finance for quantitative modeling, tech for web services, healthcare for analysis, research for every imaginable field. Its broad applicability, driven by those early CP4E goals, makes it economically indispensable.
And we can't talk about popularity without mentioning the TIOB index, which tracks the popularity of programming languages based on global search engine results. It's a measure of general public interest in learning.
Python's performance on the TIOB Programming Community Index confirms its long-term stability and its incredible growth trajectory. It has been consistently among the 10 most popular programming languages every single year since 2004.
Which is incredible longevity.
It is. And even more significantly, it achieved the #1 spot on the index in October 2021, and it continues to trade that top spot. This isn't fleeting popularity. This is a sustained position as a reigning champion.
This level of global impact inevitably leads to massive professional recognition. And Guido van Rossum has received a wide breadth of awards, showing his influence across technical, open source, and historical sectors.
His awards really trace the history of modern computing's evolution. Early on in 2001, he received the award for the advancement of free software from the Free Software Foundation, the FSF. This recognizes Python's commitment to community and openness right from its foundational years. Then in 2003, he received the NLUG Award, acknowledging his crucial impact within the Dutch computing sphere.
And the recognition moved pretty quickly into the established institutional pillars of computer science.
Yes. In 2006, he was recognized as a distinguished engineer by the Association for Computing Machinery, the ACM, placing him among the academic elite. Later, in 2018, he was made a Fellow of the Computer History Museum, an honor that formally recognizes him as one of the major figures who shaped the digital age.
It's also nice to see his original academic home recognize his achievements, even after he'd moved on to global tech giants.
Definitely. In 2019, he was awarded the honorary title of Dijkstra Fellow by CWI, the Centrum Wiskunde in Informatica, his initial workplace. And most recently, in 2023, he received the prestigious CNC Prize by NEC Corporation, specifically for developing the language that enables so many global innovations. This comprehensive list just underscores that his legacy is about far more than code. It's about fundamentally changing the tools that humanity uses to solve problems.
He started with an academic grounding that allowed him to see system design with mathematical elegance. He infused it with open source principles for rapid growth, and then successfully guided that project to global dominance before gracefully passing the torch.
That's the perfect synthesis. The academic foundation from the IMO and the University of Amsterdam, the influence of ABC and Settle, ensuring that high-level structure, the casual yet rigorous Christmas hobby origin.
And those clear philosophical goals of the CP4E.
Exactly. Intuitive power, open source, English-like readability, and suitability for rapid everyday tasks. Yeah. All of that combined to create a language that was just built to last.
And his career arc, the roller coaster, the startup phase, the stabilizing, crucial backing of Google, the real-world refinement at Dropbox where pressures informed features like type annotations, and finally his return to Microsoft, it all reflects the dynamism of modern software stewardship.
The metrics confirm it all. Python is currently operating at its highest peak of relevance, achieving the #1 spot on the TIOB index, and crucially, overtaking JavaScript on GitHub in 2024, demonstrating its central role in the age of AI and data.
But this deep dive into his life story leaves us with a truly interesting and maybe a little provocative final thought for you to consider: the learner. Van Rossum created a language based on community and open source principles. He committed to that community by stepping down as the benevolent dictator for life to allow for a democratic governance model.
He fulfilled his institutional duty perfectly. Yet he then found retirement boring and returned to the industry, specifically joining a massive corporate entity like Microsoft with the stated goal of actively improving Python's core performance and ecosystem.
So we have to ask a profound question about technology and stewardship. In the world of open source, where the community is supposed to be self-sustaining, is the job of the original creator ever truly finished? Does the ongoing commitment and active, hands-on involvement of a founder, even after the official transfer of power and retirement, fundamentally change the nature of a technology's leadership?
It really suggests that governance can be democratized, but the passion, the foundational vision, and the deep, guiding technical knowledge of the original architect remain an incredibly powerful force. Maybe the title BDFL was always less about governance and more about a calling, and maybe that calling doesn't end with a resignation letter.
That's a deep thought about legacy and commitment. Thank you for joining us for this deep dive into the life and philosophy of Guido van Rossum. We encourage you to delve further into the community he built, perhaps starting by reading the foundational text of that community's philosophy, the Zen of Python.